Hello everyone, I'm Jesse Mason, and in this edition of Teach Me, we'll learn how to solve a system of linear equations using Gauss-Jordan Elimination, aka the matrix method. For our example, we'll be solving three equations with three unknowns. This particular system of linear equations comes from another Teach Me video, for which this technique is used to determine electric currents in a circuit, represented here by variables I1, I2, and I3. So the first thing we want to do when applying the matrix method is make sure that the variables are in the same order for each equation, and if any variables are missing, use a 0 for its coefficient, like we've done here for I3. Good. Next, we want to superimpose the augmented matrix right on top of our equations. This makes identifying coefficients as easy as 3.141592697. So the first row of entries in our augmented matrix will be 8, 6, 0, and 2. In the second row we have 2, -8, 5, and 4. Third row, -10, 10, 15, and 8. Now before we attempt to transform this 4x3 augmented matrix to row-reduced echelon form, we need to familiarize ourselves with the three tools associated with this technique. They're called elementary row operations. Our first tool is called row switching, notated with a left-right arrow between two rows. For our purposes, we'll use generic rows I and j. This notation denotes that we interchange the positions of row I and row j. Simple enough. Next we have row multiplication, which is where we multiply row I by a non-zero scalar, creating a new row I. A little trickier. Now the last tool in our ERO toolbox is called row addition. When we use row addition, we add row I to some scalar multiple of row j, creating a new row I. This one has been known to cause a few headaches. By the way, when we say multiply row I by a non-zero scalar, what we really mean to say is multiply each of the entries in row I by that non-zero scalar. Likewise, when we say add row I to row j, what we really mean to say is add each of the entries in row I to each of the corresponding entries in row j. Okay, we're ready to apply our elementary row operations to our matrix to transform it to row-reduced echelon form. And what row-reduced echelon form looks like is a diagonal of 1s to the left of that vertical line, with all other entries to the left of the vertical line being 0. So in place of 8, -8, and 15, there'll be 1s. And in place of these other entries here, there'll be 0s. And this column will represent the solutions for each of those variables. Okay, let's begin. We'll start by targeting the lower left-hand entry. This -10 here needs to be a 0. The way we'll accomplish that is using row addition. We're going to multiply row 2 by 5 and add row 3 to it, replacing row 3 with the result. Since we're not operating on the first two rows though, we'll just rewrite them. Now we'll do 5 times 2 plus -10 gives us 0, which is exactly what we wanted. Now we do 5 times -8 plus 10 gives us -30. 5 times 5 plus 15 gives us 40. 5 times 4 plus 8 gives us 28. Good. Now we're going to target the 2 above the 0. This 2 needs to be a 0 as well, and we'll accomplish that using row addition again. We'll take row 1 and subtract 4 times row 2, replacing row 2 with the result. You say subtracting, and I say adding a negative. Let's call the whole thing off. So 8 minus 4 times 2, that gives us a 0 we want. 6 minus 4 times -8, that's going to give us 38. 0 minus 4 times 5, that's a -20. And 2 minus 4 times 4, that's going to give us -14. And we simply rewrite the third row. Okay, now at this point all of our entries are even numbers. So we're going to do 3 steps in one, multiplying each row by 1/2. And that brings us to Funky Town. The land of funky fractions. You see, we need this -15 to be a 0, and the only way to do that without changing the 0 next to it is to use row addition with the second row, creating a funky fraction with the 19 here. So we'll take row 2 and add 19/15 times row 3, replacing row 3 with the result. So the entries in the first two rows stay the same. Then we have 0 plus 19/15 times 0, which gives us 0. Couldn't have done that with row 1. 19 plus 19/15 times negative 15 gives us 0. Negative 10 plus 19/15 times 20 gives us 46/3. Kind of funky. Negative 7 plus 19/15 times 14 gives us 161/15. That's pretty funky. Okay, so along this diagonal here, we're going to need 1s. So I'm going to target this entry. And the way we'll turn this into a 1 is multiply row 3 by 3/46. So we just rewrite the first 2 rows. And 0 times anything is 0. This becomes a 1 after that multiplication. And then this one, let's see, 346 times 161/15 is surprisingly 7/10. So we have our first solution, which merits a smiley face. Okay, now we're going to target the negative 10 here. This needs to be a 0. And the way we'll do that is take row 2 and add 10 times row 3 to it, and then replace row 2 with the result. So we rewrite row 1. So first entry 0. 19 plus 10 times 0, that's 19. Negative 10 plus 10 times 1, that's 0. Negative 7 plus 10 times 7/10, 0. Nice. And we rewrite row 3. Okay, so the final step we'll take to obtain our second solution is multiply row 2 by 1/19. This is probably the easiest elementary row operation we're doing today. And quite an interesting solution, I might add, meriting a smiley face. Hey, it's the simple pleasures, right? The last refuge of the complex. Okay, we're in the home stretch here. We're going to target this 3, which needs to be a 0. The way we'll do that is take row 1 and subtract 3 times row 2, replacing row 1 with the result. Gives us 4 in the first entry, a 0 here, a 0 here, and a 1 here. And rows 2 and 3 remain unchanged. All right, last step. This 4 needs to be a 1. In order to do that, we'll multiply row 1 by 1/4. That gives us, in the first entry, a 1, and then a 0, and this will be 1/4. And we're done. And that is what row-reduced echelon form looks like.
That's hot.
Yes, it is, Paris. Yes, it is. So our solutions are I1 is equal to 1/4, I2 is equal to 0, and I3 is equal to 7/10. And that is how you solve a system of linear equations using a matrix. I'm Jesse Mason. I hope you found this video helpful. And until next time, happy learning.